Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Right. Question 6 of the 2020 paper was a mix of differentiation and integration. So part A, differentiate 3x minus 5 by 2x plus 4 with respect to x from first principles. Okay, so first principles, you have to know the formula off by heart. It's not written anywhere. It's the limit as h tends to 0 of f of x plus h minus f of x all over h. Okay, your f of x is what's given in the question. Okay, so f of x is equal to 3x minus 5, 2x plus 4. And you tend to try and write that in its simplest form. So let's multiply it out. Okay, so 3x by 2x is 6x squared plus 4 3s are 12x minus 5 2s are 10x minus 20. So I have 6x squared plus 2x minus 20 for my f of x. Okay, so I'm just going to put a little line under that. That is my f of x. The differentiation from first principles is often taught as 5 steps. So that's your first step where you've established a formula or an expression for f of x. Step 2, you establish an expression for f of x plus h. Okay, so I'm going to change color just so in case anybody is following the steps. F of x plus h. So for this, anywhere there was x in your f of x expression, you replace with x plus h. So that's here and it's here. Okay, so I'm going to have 6 times x plus h to be squared plus 2 times x plus h minus the 20. Okay, anywhere there was x, there's now x plus h. So I need to multiply this out. Okay, you always do the squared first before you multiply in the 6 because of the rules of BOMDAS. Okay, that order, that powers comes before the multiply. So it's 6 times x squared plus 2xh plus h squared. That is just me multiplying out x plus h by x plus h. You get really fast at it when you've done the first principles a few times. Plus 2x plus 2h minus 20. Let's multiply in the 6. 6x squared plus 12xh plus 6h squared plus 2x plus 2h minus 20. Okay, and generally there's not much tidying up you can do on that. So that's step 2 done. Step 3, so that's step 2. Step 3, we subtract them. Okay, so let me change color again. F of x plus h minus f of x. So I take them away. So for x plus h, I write what I have here in blue. So 6x squared plus 12xh plus 6h squared plus 2x plus 2h minus 20, and you subtract off that all of f of x. Okay, look at my big square bracket going in, okay, to make sure that you don't make the mistake of writing it down like this. Okay, because that's not correct. It's minus all of this, and that minus ripples through the whole expression so that it becomes minus x squared for sure. It then becomes minus by plus, so minus 2x, and it becomes minus 20, so it'll be a plus 20. So write it down with the brackets to avoid you doing this. Okay, that's wrong. So ripple through that minus, and I made a mistake. That should be a minus. Okay, so I've just multiplied in that minus there now, okay? And you can write all of this down again if you want. I tend not to, I just kind of go there. And a little trick of the trade, everything in f of x should cancel with something backstream in f of x plus h. Okay, everything should cancel. So there's my minus 6x squared, my 6x squared. There's my minus 2x with my 2x. There's my plus 20 with my minus 20. And you've made a mistake with signs or with something if everything in f of x does not cancel out. So that everything that you're left with now has a h term in it. Okay, that has to happen. So I'm left with 12xh plus 6h squared plus 2h. Okay, so that's f of x plus h minus f of x. Okay, so that's the third step. The fourth step then is this dividing by h. Okay, so let's do that. F of x plus h minus f of x all over h. So that's 12xh plus 6h squared plus 2h over h. And this h divides into each term. Okay, you cancel a h with each term. So that's it with the first term. In the h squared, well, h squared is h by h, so I tend to cancel out the squared bit so that I'm left with just the h. And then, of course, h and h cancels there. So you're left with 12x plus 6h plus 2. Okay, so that's the fourth step. And the fifth step then is the limit. Okay, let's find a colour for that. Let's go orange. So the limit as h tends to 0 of f of x plus h minus f of x all over h, okay, means we take this gap that's between x and h and we make that gap be as small as possible, okay, so small in fact we let it approach 0 so that it is practically 0. So everywhere there's a h in your expression, let it be 0, okay? So in other words, the gap is so small. So I'll have 12x plus 6 times 0 plus 2. 6 times 0 is 0, so I'll have 12x plus 2. Okay, so that is what I am getting for that function differentiated. Have a look up here, differentiate by rule using the log tables, okay? Using this as you normally would if you got at it, differentiate 6x squared, we'll take down the power, 2 6s are 12x, cool. Differentiate 2x and you get 2, and of course the 20 disappears. So you know that's right. Okay, so that's your differentiation by first principles. It was actually 15 marks assigned for that, so well worth knowing how to differentiate from first principles. B part 1 then in that question, h of x is equal to half times ln of 2x plus 3 plus c, where c is a constant. Find h dash of x, the derivative of h of x. Okay, so we are, sorry, I'm trying to delete. We are differentiating ln's. Okay, so ln's goes to 1 over x. Okay, so let me write down that rule. Ln of x is equal to 1 over x. Okay, that's f of x. This is f dash of x. So my main function in this is ln. Okay, so let's differentiate it. So h dash of x equals to, well, a half is just a constant, so we always keep our constants. Differentiate ln of 2x plus 3, and you get 1 over 2x plus 3. Okay, it is a chain rule. In other words, this inner function, our main function is ln, but our inner function is 2x plus 3. And can that in itself be differentiated? Yes, it can. The 2x can be differentiated and you get 2. Okay, so that is the chained part there. Okay, and our constant c, well, if you differentiate any constant, you always get 0. Okay, so I have 0 for that constant that's out here. Okay, so a half by this by 2. The half and the 2 is going to cancel. So I'm going to be left with h dash of x being equal to 1 over 2x plus 3. Okay, that was that part. Part 2. The diagram below shows part of the graph of the function h dash of x. 1 over 2x plus 3. Okay, the shaded region in the diagram is between the graph and the x-axis from x is equal to 0 to x is equal to a. This shaded region has an area of ln of 3 square units. find the value of A. Okay, so to get the area under a curve, we use integration. So I would like to get the area between 0 and A of h dash of x dx. Okay, so this is the area between 0 and A of 1 over 2x plus 3 dx, and we have the answer. We know it's equal to ln of 3. Okay, so let's integrate this one. Okay, if you integrate 1 over x, you won't be too surprised to find you get ln of x, okay? And integration and differentiation are the opposite of each other, so that makes perfect sense. Okay, so if I integrate him, I get ln of 2x plus 3, okay? And the 2 under the line means I need this constant of a half. Okay, and that's between 0 and A, equal to ln of 3. Okay, if that bothered you, then, and you know that integration and differentiation are the opposite of each other, you can of course take this and go back up here to get your original answer. Okay, so in other words, these are the opposite of each other. If you integrate an integrated function, you get back to the original. Okay, before you differentiated it in the first place. So half ln of 2x plus 3 is what I would expect you to get. So you can either integrate it or you can know to return back to the original. Either way. Okay, so let's do that one. So we are going to get a half of top minus the bottom. Okay, so we are going to have ln of 2a plus 3, okay, minus the bottom, ln of 2 times 0 plus 3. Okay, and it's equal to ln of 3. Let me come up here and continue it. Well, let me rub him out. I come up the top in case I need the space. So where are we? A half of ln of 2a plus 3. So let's tidy him up. I have a half of ln of 2a plus 3 minus, what have I here? Just ln of 3, okay, because the zeros disappear. So minus ln of 3, and we know that's equal to ln of 3. Okay, so before we can get rid of the ln's, we need to tidy this up using the rules of logs. Where's my rules of logs? Here. So when it's a minus, you can write it as a division. Okay, so we have ln of a function minus ln of a function. So that's the same as ln of one over the other. So let's write it as that. To a plus 3 over 3. And we know that's still equal to ln of 3. Okay, I still can't apply the rules just yet until I get rid of this half from the front. Okay, because what I'm going for is ln of a function equal to ln of a function, and then I can get rid of the ln's. Okay, that's what I'm going for. So I need to get rid of this half that's there. So let's use the Q rule, as I call it. And when there's a number in front, it's the power. Okay, these are the opposite of each other. When something's a power, you can always bring it down in front. If you have a number in front, you can always bring it up to be the power. Okay, so what does that mean here? Well, that means I can write this as ln of 2a plus 3 over 3 to the power of a half equals ln of 3. Okay, and now again, using the rules of indices, I have ln on both sides, which is a log function in the middle. If I raise both sides to the power of e, they will cancel. So let me explain that. Always remember that ln is the same as log to the base e. Okay, so if I write this as log to the base e, so that's the same thing as ln. Okay, log to the base e is so common that it got its own name, which is the natural growth rate, which is ln. Okay, so if I raise both of these to e, to the power e, so that I have e log to the base e of 2a plus 3 over 3 to the power of a half equal to, and raise what I do to one side, I have to do to the other. What ends up happening is log and e cancel each other out because they're the opposite of each other. Powers and logs, indices and logs are the opposite of each other. So I'm just left with the functions themselves. Okay, so now I have 2a plus 3 over 3, okay. Power of a half, you may know from integration or from differentiation anyway, anything to the power of a half is square root. Okay, so how about I write this as square root, and it might look a little bit easier, and it's equal to 3. Okay, so the other thing I've done there is the power of a half is the same as square root. Okay, now I'm going to square both sides to get rid of that square root, so that I have 2a plus 3 over 3 being equal to 3 squared, which is 9. Okay, let's multiply across by 3. Let's bring up that 3. So that I have 2a plus 3 being equal to 9 threes, or 27. I'll bring that 3 up so that I get 27. Okay, let's bring across the plus 3 to become minus 3. So 27 minus 3 is 24. Divide across by 2. So I'm getting for a, I'm getting 12. Okay, so this value here that we integrated between was 0 and 12. Okay, so just 5 marks for that part 2, and that was that question 6.
If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.